Hello friends, welcome to lecture number 12. In today's class, we will establish a relationship between the electric field and the potential difference. Okay? So we will be finding out the relationship between electric field and potential difference. Potential difference, as we have read in the previous class, it is VA minus VB if there are 2 points, which can be written as delta W, delta V and dV. Okay, these are the few notations. Followed. Now I have taken a source charge Q, and that source charge is going to produce an electric field in this direction. Okay, I have taken 2 points, point A and B. Suppose if a charge Q is moved from B to A, then what will be the force? F vector will be charge into the electric field. Okay, now to have a small displacement, dx, which I have taken this one, dx. The small amount of work done will be f dx cos theta. Okay, now what will be theta here? As usual, we know theta will be 180 degree. From the previous classes we already know it. So cos theta will be -1 in this case. So what will be dw? Force is nothing but QE, and cos theta will give you -1 and dx as usual. So what we have, dw by q is equals to minus e dx, and what will be this one? This will give you dv is equals to minus e dx. Okay, this implies e will be how much? Minus dv by dx. So this is the relationship. This comes for a 2-mark question. So this is the relationship between electric field and your potential difference. Okay, now this equation can also be written in a general form. The general form will be dv is equals to minus electric field dot dr vector. R vector means position vector. This will be using while doing some problems also. Okay, now let us try to understand what is the physical significance of the relation E is equal to minus dv by dx. Okay, so the negative, what is the negative sign indicates? The negative sign indicates that the potential, it indicates that the potential increases in a direction opposite to the electric field. So let me take an example so that it will be clear for you. So let me take an example. Suppose I have got two plates, plate A and plate B. Okay, plate A is 5 volt and plate B is 50 volt. Okay, so what we see, that the potential is increasing in this direction. So what will be the direction of the electric field? It is opposite to that of the increase of the potential. So the electric field direction will be in this direction. Okay, so I hope with this example it is clear to you what does this negative sign signifies. Okay, let us do a problem. So it is given there are two plates. The distance between the two plates is given as 0.25 meter. So this is plate A, this is plate B. Okay, and the electric field is given in this direction. And your electric field mod, that means the magnitude of the electric field, is 20 unit. Okay, now what is asking? The question is, what will be your dV? And what should be the direction? Moreover, it is also given that the plate B is having a potential of 30 volt. Okay, so it is asking what is your dV and what is the potential at A. These are the two things which you have to find out. Okay, this is a very common question. So first let us find out dV. We know The answer is, we know dV is equals to EdR. So E is how much? 20 units. And the distance between the two plates is 0.25. Okay, so what will be your dV? It will come out to be 5 volt. Okay, now you see this is 30 volt. Change in the potential difference is how much? 5 volt. So either potential at A can have two options, less than 30 minus 5, that is 25 volt, or it can have 35 volt. Now what I have to choose? Since my electric field is increasing from plate A to plate B, then the potential has to increase in the opposite direction. That means the potential will increase in this direction, the blue color which I have given. So the potential at B is less and potential at A should be more. Therefore, it should be 35. So 35 should be the answer. So potential at VA will be greater than potential at BB because of this direction. Therefore, so your potential at A will be how much? 35 volt. Okay. So this is a very common question which comes, or else the derivation will come. Next important topic which I am going to cover in this class, that is your equipotential surface. That is your equipotential surface. Okay. So as the name suggests, any surface, equi means what? Equi means same. Equi is your same. So this has to be same. So okay, so what will be same? The potential is going to be same. So any surface you choose whose potential is same, that will be called as an equipotential surface. So let us go for their properties. Properties of an equipotential surface, we'll study one by one. The first thing what it is that these are your imaginary surfaces. These are your imaginary surface. Okay, then the second property, that electric lines of force are always perpendicular to these surfaces. They are perpendicular to these surfaces. The third point, two surfaces cannot intersect. What is the reason? Because at the point of intersection, it will have two potentials which is not possible. Okay, so they cannot intersect. The fourth one depends on the formula. Your work done is equals to charge into change in that potential or the potential difference. So the two surfaces, any surfaces will have, suppose this is a surface and I have got 2 points, point A and point B. So what will be dV? It will be 0 in this case. Why? The potential at A and potential at B will be equal. So the potential difference will be 0. So if this goes to 0, then what will be the work done? It will also go to 0. So what statement can I make from this? That the work done in moving a charge from one point to another in an equipotential surface is how much? Is 0. Okay, so this is the fourth one, which is very very important. Then coming to the fifth one, we know that the relation just now we have derived, E is equals to minus dV by dx. So from this what I can have? I can have E is inversely proportional to dx. Then the question comes, what is dx? Dx is basically, it is the distance between the two equipotential surfaces. Equipotential surfaces. Okay, so this is the distance between the two equipotential surfaces. So what does it mean? This expression, what does this expression mean? It means that your electric field will be high if the electric field will be high, the equipotential surfaces will be closely packed, will be closely packed, and vice versa, okay. So now let us construct few of the equipotential surfaces. Okay, now if a charge of plus q is given to you, suppose a charge of plus q is given to you. Okay, now how do you construct? First of all, I have to construct the electric field lines. We usually know how it is outward in this manner. It is quite clear. Okay, similarly in this direction, similarly in this direction. So this is the electric field lines. But what about the equipotential surface? How to construct it? We very well know that the electric field lines is perpendicular to the equipotential surface. So we draw a equipotential surface in this manner. Okay, fine. Then we will draw the next equipotential surface. It will be somewhere here. Okay, then we will draw some another equipotential surface. Okay, then another equipotential surface, let me draw it. Right, so what you observe, as we go away from this, suppose I take a point, suppose this I take a point A here, I take another point B here. So it is quite obvious that the electric field at A is greater than electric field at B. So if electric field is high, electric field will be high. What about the equipotential surfaces? They are closely packed. So as we move away from the plus q charge, we see that the distance between the two equipotential surfaces is going on increasing, which is exactly matching with the fifth property of the equipotential surface. I hope it is very clear to you. So this is the first case. Let us go to the second one. In the second one, what we have is, we will have two charges, basically let us consider a dipole, plus q here, another one minus q here. Okay, let me take it a bit closer. So let me keep it as plus q here and minus q here. I'll have two charges, basically a dipole. Then how will the field lines be? We already know how the field lines will be. It will be in this manner, and they have to be symmetric. I have already told in the previous classes. So it will be in this manner, from plus to minus. So these are the electric field lines which I am drawing. Okay, few more we have to draw. So these are the field lines basically. Okay, what about plus q? It will be in this manner. Okay, so these are the field lines. Now how to construct the equipotential surface? This is very important. Please try to mark it. Okay, so the first equipotential surface, let me draw it here. Okay, the first equipotential surface for this side will be this one. So these are the equipotential surfaces which I have drawn. Okay, so in the next second equipotential surface, when I will draw, I'll see can you mark the difference? You see this spacing, this side spacing is increasing, whereas the other side it is decreasing. Okay, it will be something like this. Okay, so this is the figure or the equipotential surfaces for a dipole. I hope this one is clear. Let us go to the third case. In the third case, what we'll do, we'll take two charges of same magnitude and same sign. Same magnitude and same sign. So first I have to draw what? We have to draw the electric field lines. So electric field lines, as we know, already we have drawn it. We'll get a neutral point in this case along these directions. Okay. Clear? So these will be the directions. If you remember properly, this was what was your neutral point. Okay, that is not required for the time being. So now let us draw the field equipotential surface. So the first equipotential surface will be a spherical one in this manner. Same here also. Okay. Now you will see that this side will be closer and this side will be bit farther. Okay. Right. Let us do for the other side also. Here this side will be closer, but this side will be farther. Okay. Understood? So this is how will be the equipotential surface. So these are the equipotential surfaces. So everywhere the yellow color represents the equipotential surfaces, whereas the red color or the pink color, it represents your electric field lines. Okay, this is the third case. In the fourth case, let us see. In the fourth case, what we'll have, we will have uniform electric field. So how this uniform electric field gets represented? Let us see. We know that the uniform electric field lines are represented by parallel lines in this manner. Okay, so these are the basically your uniform electric field lines. So to these uniform electric field lines, what should be your equipotential surface? So your equipotential surface will be the plane which cuts basically the parallel planes which cut the uniform electric fields. It will be in this manner. Okay, it will be in this manner. So these are your equipotential surfaces. So these are your equipotential surfaces for whom? For the uniform electric field. Okay, then the fifth important question which comes, that an infinite charged rod will be given to you. Infinite charged rod will be given to you. So let me do it. Infinitely charged rod will be given to me in this manner. Okay, since it is infinite, let me produce it with by dotted lines. So this represents that it is an infinite charged wire. Infinite charged wire is like this. Okay, now suppose I take the electric field lines in this manner, positive, positive. So the field lines will be coming out in this manner. So these are the field line directions. Okay, fine. Now what should be the equipotential surface? So for this, the equipotential surface will be cylinders. The equipotential surface will be your cylinders. Okay, cylinders will be your equipotential surface. Now what about the next cylinder? It will be bit farther. Which principle? The fifth property. What is that? Electric field is inversely proportional to dx. So equipotential surfaces are going very far away. They are very far away. Okay, so this is how the equipotential surfaces for this infinite charged wire looks like. Okay, and sixth one is a problem which usually comes in the entrance as well as in CBSE, everywhere. Let us try to see what that question is. Basically a graph is given to you. You are given with a graph, right? In this graph, what you see will be some parallel lines are given to you. Few parallel lines are given to you in this manner. This is one of the lines. The other line which I'll show you in this manner. Okay, just 1 second. This is the line. Then another line is given. Right? So these three parallel lines are given to you. And it is given this is 10 volt, this is 20 volt, and this is 30 volt. Now what is there in x-axis? V in volt is there in this axis, and what is here? X in centimeter along this axis. So this distance is equidistance is 10 centimeter, this is 20 centimeter, and this is 30 centimeter. And it is given that each equipotential surface, these are the equipotential surface. So 10 volt, 20 volt, 30 volt, they are the equipotential surface. Now it is given that each equipotential surface is inclined with the x-axis by an angle 30 degree. Everywhere it is inclined by an angle 30 degree. Okay. So now what it is asking? It is asking to find out the electric field. Now how to solve this? So the 10 volt, 20 volt, 30 volt, they are the equipotential surface. You have to find out their electric field. That means you have to find out the electric field mod and electric field cap. That means magnitude bhi chahiye, and you need to know the direction also. Okay. Now for this, what you find, what is this? This is your delta R. Difference between the two equipotential surfaces is delta R. Now how these electric field lines are with respect to the equipotential surface? We have read the second property, it is perpendicular, it is normal to the equipotential surface. So if I draw a line like this is your electric field which is normal to your equipotential surface here as well as here. Okay. Now we know the relation, an important relation which we have already read. Your delta V is equals to minus E vector dot delta R vector. They are dot product. So if I expand it, so it will be E delta R cos theta. And what is theta? Theta is the angle between your x-axis and your electric field. Okay. So this one and this one. So this is 30, this is 90. What is the total angle? This total angle will be how much? 120 degree. So in this problem, my theta is 120 degree. So if I want to find out the electric field, minus delta V by delta R cos theta. So what is delta V here? This is 10 volt, 20 volt. So delta V will be everywhere you see it is 10 volt only. So minus 10 divided by delta R is how much? Everywhere you see 10, 10, 10, 10 like this. So it will be 10 into 10 to the power minus 2. Why? I have to convert it to meter. That's why 10 to the power minus 2. Divided by cos theta, cos 120 degree. So 10, 10 gets cancelled out. Minus 10 to the power 2 divided by cos 120 is minus half. So minus minus is gone. So it will be 200 volt per meter. Okay. Then what is this is the magnitude. This is your magnitude. And what about the direction? E cap, what is the direction? Direction is 120 degree with whom? With x axis. Okay. So this is it for today's class. We have started with the relationship between electric field and your potential difference. We have studied about equipotential surface. Okay. So I would like that everybody should kindly like the video, share the video, and do subscribe my channel so that it will motivate me to go on making some more interesting videos like this. Any queries you have, kindly email me in the mail ID which is given below. Okay. So thank you for your kind patience.